tomorrow we have a test over multiple reps, so make sure that after you've gone over your review, you go ahead and get it signed by your parent. We've talked about a lot of different vocabulary in this unit, so we need to make sure we're very, very clear on it. A bike can travel 5 miles per hour. Well, first of all, we need to know per means multiply. But also, whenever we were doing our linear representations, our linear explorations, we learned that it's always going to be y per x. And that's going to help us with our independent and dependent variables. Remember, independent is x and dependent is y. Also, I want you to look at this. When you see that, you can see that we could even write 5 miles every 1 hour. And this is actually our m, our slope, our rate of change, because that is how our y's are changing every x. So we need to make sure that in our table, we label our independent and dependent. So we know in a table, we learned it's always x when it's horizontal on top and y on the bottom for independent and dependent. And we know miles, this is our dependent, and hours is our x, our independent. So when we make our table, we said we're going to start at 0, 3, 4, you could even go to 5 over here. And so we know that if it's 5 miles in 1 hour, at 0 hours we've gone none, at 1 hour we've gone 5, and then you should be able to see this change, right? So we're adding 5 every 1, okay, and so 10 and 15, 20 and 25. We should be able to write an equation at this point where they have d as your distance, the bike can travel in t hours. So remember, so we are over here, we're at miles or hours, so they're wanting us to use d and t, which is fine. That's going to help you with your equation. We know it's proportional, so it's just mx. But instead of y, they want us to use d. And instead of x, they want us to use t. And we said our rate of change was 5. How long will it take to travel 54 miles? So now you're plugging into this equation. We're applying it. We said miles was our d. So we're going to plug 54 in place of d. And we're going to use what we know about equations to solve this. We're multiplying, so the inverse is to divide. 1. 5 does not go into 4, so we can bring down a 0. We can say t equals 10.8. Let's make sure we label that with hours. Make sure you have some units. You could also write 10 and 4/5 hours. Again, on this next one, we're applying it. So we have 12 hours. Hours is our t, which is our independent variable. So we're going to put this 12 here. d equals 5 times 12. So 5 times 12 is 60. 60, and we are using miles. Sam and Lacey have a friend, Amy, who moves according to the equation d equals 3.25 m. And then it's different here, so we're going to actually scratch out the 2. This is a typo. And I'm going to tell you here, distance is going to be meters, and m is going to be minutes. Solve the equation, 42 equals 3.5 m. Explain the solution to the equation in the context in a complete sentence. So we need to solve this equation. When we know how to solve equations, we're multiplying m by 3.5. So instead, we're going to divide. Now, when we divide with a decimal, we've learned you cannot have a decimal outside. So we're going to move it over 1. If we move it on the outside, we have to move it on the inside and bring it up. 35 doesn't go into 4. 35 goes into 42 once. Don't forget to borrow. 7, bring down the 0. 35 goes into 70 twice with none left over. So that means that m equals 12. So how do we write a sentence representing this information? We can say m was minutes, so it took Amy 12 minutes to go, and then they gave us D was 42 meters. So make sure that you are using appropriate labels. Now, because you didn't know D was meters, if you put miles or distance, that's fine. Now, this one we need to solve the equation. This is like what we plugged in on number 12, our letter D up here with the 12. So we're going to have to multiply. Be careful when you multiply with decimals. And also, I'm finding some of you are forgetting to use your second number. You're stopping here. So this is 20. 12 and 2 is 14. We have one number behind the decimal, so we're going to move it one. And this is our D. So we can say it took Amy, because that's who we're talking about. This was your M, right? 42 minutes to go 147 meters. Or miles, whatever unit you used for distance. Sally makes 4 rugs a week. Notice that this 4 is written out, so be careful there. So we have Y and we have X, rugs in 1 week. So let's show the number of rugs she completes over 4 weeks. Label independent and dependent. So remember X and Y. So just like what we did on number 1, X and Y, we have weeks and we have rugs. You can start at 0 if you like. You can start at 1. 1, 2, 3, 4. If it's 4 rugs a week, then in the first week she's made 4, 8, 12, and 16. Where that 4 rugs in 1 week. That's that change in Y over change in X. This is our slope. This is our M value, right? Because we're adding 4 every 1 week. Okay. On the back, it's going to ask us to graph it. This is not a great scale. You do need to make sure that you label your axes. Remember, X is across, is horizontal, and Y is vertical. So our X, our independent variable, was weeks, and our dependent was rugs. So we're not going to get a whole lot on here based on the scale. If you wanted to change the scale by 2s, you could fit more. But we'll leave it the way it is. 1 week, we had 4 rugs, and in 2 weeks, we had 8 rugs. Write an equation to represent the number of weeks and the number of rugs. So remember equation, Y equals mx. So we just said on the front our M was 4, and you can see it here, right? Remember, that's your rise over run. So we're going 1, 2, 3, 4 rugs in 1 week, right? So 4 over 1, which is the same as 4. So we can write Y equals 4x. Describe each of the variables as independent or dependent. So remember, when we write our dependent sentence, the dependent variable depends on the independent variable. So we said, based on dry mix, right, the number of rugs depends on the number of weeks. How many weeks will it take her to create 12 rugs? So rugs, again, that was our Y. We put that as our dependent. So we're going to plug this 12 here into the equation. 12 equals 4x. And make sure you're showing those steps. We're multiplying, so the inverse is to divide. 3 equals x. So it will take Sally 3 weeks to make 12 rugs. After buying 3 rugs from Sally, Nad was inspired to create. He makes 1 rug a week. Who will have more rugs over 5 weeks? So if we think about this, we can make a little comparison. Sally can make 3 rugs. I'm sorry. Was it 3 or was it 4? It was 4. So going back to our equation, she can make 4 rugs a week, and we have 5 weeks because weeks was our X. So in 5 weeks, Sally will have 20 rugs based on this equation. Nad, he's bought 3 rugs from Sally. So he has 3, and he's going to make 1 rug each week, and we have 5 weeks, right? So again, weeks is our X. So 3 plus 5. So in 5 weeks, Nad will only have 8 rugs. So the question is, who will have more rugs over 5 weeks? There should be an S there. Sally will have more rugs in 5 weeks because it wants us to write a complete sentence. And as long as you're showing your work, you're justifying that. We did scientific notation a while back, so we'll just have a little review of that. If you remember, we watched your brain pop on that, where we had some number between 1 and 9, right? It couldn't be 2 digits here, times 10 to some exponent, and this was the number of decimal places we moved. So if we have 0.00045, the first number that I come to when I read left to right, that is between 1 and 9, is 4. We're going to put that 5 there. So I want my decimal now to be between the 4 and the 5. So I'm going to count my loop-de-loops. I'm going to count 1, 2, 3, 4 loop-de-loops. That's how many decimal places moved. And this is a small number, so we said that exponent needs to be negative. If it's a big number, it's going to be a positive. Number 6, Houston. This is not incorrect scientific notation, but that's okay. 52.4 times 10 to the 4th. After 10 years, it's 55.2 times 10 to the 5th. What is the increase in the population in scientific notation? Well, first we got to change this. So we can say 52.4 times 10 to the 4th. This is a positive exponent. That means the number is big. So we're going to move our decimal 1, 2, 3, 4 places to the right to make it big. And then we have 55.2. This is 1, 2, 3, 4, 5 places. So if we want to know how much it went up, we need to subtract these. So we're going to say 5, 5, 2, 1, 2, 3, 4. Put my commas there so I can line everything up. I've got a comma here. 0, 0, 0, comma, 4, 2, 5. So we're going to have to subtract these. Now be careful when you subtract. Some of you are really struggling with your borrowing. This becomes a 4, that becomes an 11. You can't do that. This is a 4, this becomes a 14. 10 minus 4 is 6. 11 minus 2 is 9. 14 minus 5 is 9. And then we have a 4. So 4,996,000. That's great, but we need to put this in scientific notation. So my first number is 4.996 because those are necessary. Times 10. So the decimal is way back here. We're going to count 1, 2, 3, 4, 5, 6 because this is where I want it to be between this 4 and this 9. So it is a positive 6 exponent because this was a big number. Study, and if you have any questions, send me an email.